everybody. Sorry, a few technical difficulties, so we're starting a couple minutes late. So welcome to the 61st Annual Bay Area Science and Engineering Fair, our virtual activity week. My name is Dana B., and I am one of your co-chairs for the fair this year. There is a question and answer function where you can ask questions throughout the presentation. If time allows, we will answer your questions at the end of the session. If we are unable to answer your questions during the session, we will also post the answers to those questions on our website along with this recording of the event. Now tonight, our tour guide is John Garreau, who is the chair of the Hamilton Amateur Astronomers Council. John will be taking us on a tour of our universe, so sit back and enjoy the ride.
Thank you so much. It's an absolute pleasure to be here. I always enjoy visiting BASF. I always enjoy seeing the projects. I've done it for many, many, many years. I only wish I could see you all in person this time, but I'm happy to have an opportunity to speak to you here tonight. So we can move on to the next slide, please. I'm going to be taking you on a tour of the universe here tonight. And we're going to start close to home here and then move out through the universe. So we can have the next slide, please. So we're going to start right close to home here. We're going to start in our own solar system. Our solar system, of course, is made up of the sun and all of the planets that go around it. We can go on to the slide that shows the sun and the planets. Unfortunately, tonight we're dealing with a little delay in what we can see, so I'm just going to ask you all to be very patient while we put up with a few little pauses in the program. So here we have an illustration, and there are only a few illustrations tonight. Most of what I'm going to show you are actual photos. And I'll try to remember to point out an illustration if it is only just an illustration. And this one here shows the comparative sizes of the planets of our solar system with the sun behind it. And the planets are laid out in order as they go from the sun outwards. The tiny little marble on the lower left-hand side is Mercury. Then there's Venus and Earth. And beside the Earth, you can see another even tinier little marble, and that's the Moon. Then Mars, and then Jupiter looks so big compared to those other planets. Next to that is Saturn with the rings around it. And the two little bluish-green ones are Uranus and Neptune. And then there's Pluto and a variety of other dwarf planets. And yes, unfortunately, we have to count Pluto amongst the dwarf planets, but it's still near and dear to my heart. We can have the next slide, please. It's absolutely still near and dear to my heart. So this slide here should show us right at the very center of our solar system is the sun. And so this is how the sun would look to us right now if we could go outside and look at the sun. And actually, this photograph of the sun was taken today. It's exactly what you would see. Now, it looks like a big, bright, featureless yellow disk, and that's what we would normally see with our own eyes if we could see it. Have the next slide, please. But in fact, there's so much more going on with the sun than what we can see. This photograph here was taken at exactly the same time, and these photos are really only about an hour old, okay? So this is the sun as it is right now, and you can see how dynamic the sun is. You can see gas being thrown off of the surface. You can see it swirling around, and this is happening all the time on our sun, all right? All the time, these loops of gas going out. And if we can have the next slide, please. We can see the sun we can see the sun's atmosphere. We can see the gases being carried by magnetic fields up off the surface of the sun. Now, our eyes don't see an X-ray, but if they could, this is what the sun would look like to us. This is what would be hovering over us in our sky on a beautiful spring day like today. And this is what we would see. But we don't. We just see that plain yellow ball, of course. But this is what's happening on our sun all the time. Now, surrounding our sun are a variety of planets. We're going to start at the very closest to the sun. And if we can have that next slide, please. The sun, the planet closest to the sun, of course, is the planet Mercury. Now, when you look at this, to you, it looks like the moon. It may very well look like the moon to you. And when you and that's not oh, I'm sorry. So please go on one more slide. Please go on one more slide until we actually see the moon like Mercury. All right. If we can, when we see that. And when we look at Mercury, you can see that it's gray. You can see that it's covered with craters, just like the moon is. You can see that there's some streaks of white on it. And it looks like the moon because structurally it's built very much like the moon. So we may have to click yet once again to get to that picture of Mercury. And Mercury, just like the moon, doesn't have an atmosphere. And so it gets bombarded by meteoroids. That leaves craters on the surface. We don't see that. We don't see color on it. And if I showed you this picture, you might say it's the moon, but it is in fact Mercury. If we look at the next slide, this also is not the moon. This is also Mercury. All right, we're looking at the surface of it there. You can see the craters. That's quite extraordinary. Anybody would be entirely excused for thinking that this was the moon. So you can imagine what it's like there. Mercury's only a third of the distance from the sun that our planet is here. And being so close to the sun, you can imagine the intense heat. You can imagine the surface being bombarded by radiation from the sun. The way we're looking at there is the planet Venus. So we moved ahead on to Venus. And Venus is so very different from the planet Mercury. Venus is a completely cloud-covered planet. What you're looking at is everything that you see here is cloud. So picture here on Earth, sometimes the sun shines, sometimes it's cloudy. Here on the planet Venus, it's cloudy all the time, all day, everywhere you go, it is cloudy on the planet Venus. So now, you might, long ago when we first came to understand this, astronomers thought that underneath all that cloud, it might be rainy, it might be tropical, it might be like a jungle down there, but we know now that's not the case. Venus is intensely hot. And when I say intensely hot, I mean it's about 800 degrees, twice as hot as your oven. And the atmosphere is incredibly poisonous. The atmosphere is also much denser than the atmosphere here on Earth. When you walk around outside, you don't normally feel it, but the whole weight of the Earth's atmosphere is pressing down on your shoulders. The weight of the atmosphere on Venus pressing down on your shoulders would feel like you were holding up 2 elephants on top of your head. It's that heavy and dense. And that would absolutely crush you. Imagine 2 elephants on top of you. It would absolutely crush you. So here I want you to imagine being the very first explorer on their way to Venus. Congratulations, you're very brave. And you travel to Venus, you land on the surface, you open the door, and you are immediately cooked by the high temperatures, all right, poisoned by the atmosphere, and crushed by the weight of the air on you that weighs as much as 2 elephants. And then, after all that happens, I have to tell you that the atmosphere is full of sulfuric acid. So after you've been cooked and poisoned and crushed, then the acid in the atmosphere dissolves your body away. And if we look at the next slide, what we can see is a photograph actually taken right on the surface of Venus. And this was taken by a probe named Venera 13. You can see that in the top left corner. And this is what it would look like if you could stand there. It's dull because of the dark clouds up above you. This photograph is black and white, but it was yellowish there on the surface. And that mechanical looking stuff down at the bottom of the picture is actually part of the probe that took this photograph, all right? This was actually taken quite a long time ago, quite a number of years ago. But this is exactly what it would look like to stand on the surface of Venus. So now we can have the next slide, please. And this is a planet that looks very familiar to you, of course. This is the planet Earth. This is where you live, and this is a whole other field, right, of Earth sciences. But if you look carefully at this photo, and it's a very famous photo, and you may have seen it before, this is a photo of Earth taken from an Apollo spacecraft that was traveling from the Earth to the Moon back in the 1970s. And you can see the Africa there on the top left. Right at the very top, you can see the Arabian Peninsula. Down at the very bottom, you can see Antarctica as that solid white block. And you can see lots of clouds, of course, across there. Just to the right of Africa is the island of Madagascar. And my favorite part of the whole thing, in the top right of the picture, there in the Indian Ocean, there's a hurricane blowing there. And you can see it swirling around there in the ocean. If we look at the next slide, we can see here a closer look at the Earth. We can see the clouds sitting in our atmosphere. Earth is an extraordinary planet, a beautiful blue, rich waters covering its surface, lots of interesting atmospheric stuff, including those clouds in the atmosphere. Absolutely lovely. And Earth also has something that no other planet has that we've seen so far. And that, of course, is a moon. And if we look on to the next slide, we can see here a picture of Earth's moon. Now, you get to see Earth's moon all the time. And actually, when we're done this evening, if you go outside tonight and look up, you'll see the moon looking very much like it does in this picture right here. It's about the same phase. And you know this, you've seen it, you've seen the moon go through phases as we get to see more or less of the sunlit part of the moon. The moon, the whole moon is always there. Of course, it's always round. It's just that sometimes we don't get to see it because it's in the darkness of night. Here in this photo, part of the moon is in daylight, part is in darkness of night. And just because we're in night down here doesn't mean it's night on the moon. So you can see the daylit part there. It creates that phase. And that's the same phase that you would see tonight if you went outside. If we look at the next picture of the moon, if we go on to the next one, we can see that in a different phase. We see this moon in a crescent phase. You've seen it like this at times. It looks like a banana up there in the sky. This time we're seeing less of the daylight side, more of the nighttime side of the moon. The rest of the moon is still there. It's just in darkness, of course. And then if we go to yet the next slide after that, we see another phase, a different crescent. We see the other side of the moon. The banana has turned around, right? The banana has turned around. And in all of these images, you can see craters, you can see mountains, and you can see light and dark areas on the moon. And when you go out and look at the moon tonight, see if you can see that same phase as the first photo, and see if you can see the light and dark areas of the moon. And those light and dark areas are regions where the light areas are mountainous regions where there's lots of tall mountains and craters, and the dark areas are fields where lava has filled in the low-lying areas of the moon on the lunar landscape, and the dark lava is flat and smooth. And see if you can actually see those dark areas, those lava fields. See if you can actually see those. Now, the lava's cooled and it's solid rock now, but you can actually see that. If we look at the next picture, there's somebody actually standing on the moon. And the moon is the only other celestial body that we've actually visited in person. It's the only place we've been where people have actually gone and stood on the surface and walked around. Now, we saw that picture of Venus, and that was taken by a probe that landed on the surface, but there was nobody there. It was a fully robotic, automated probe. That picture of Mercury was taken up close by a robotic probe that was there in orbit around Mercury. But here we can see an astronaut standing on the surface of the moon. You can see here, because the moon has no atmosphere, something looks kind of weird in this photo. The astronaut is standing in the sunshine. You can see his shadow. You can see the shadow of the leg on the right-hand side, which is the leg of the spacecraft that he landed in. You can see the shadow. It's a bright, sunshiny day there on the moon. But look at the sky. The sky is completely black. Not a blue sky like we have. is completely black. And that, of course, is because there's no atmosphere on the moon. So even though the sun is shining brightly, the sky is as black as night. Absolutely remarkable. And then, of course, the next photo is one of my all-time favorites. And that was taken when they first landed, the very first people landed on the moon, and they took a step out, they put their foot down, and as they lifted their foot, they took a picture of the footprint being left behind on the moon. And that's just absolutely wonderful. What an extraordinary experience to be able to actually travel through space to another world out there. Now, there's one more photo that I'm going to tell you about from the moon, and it's one of my absolute favorite photos. And if we look at the next photo here after this, we can see the Earth rising above the surface of the moon. This photograph was taken by astronauts that actually traveled to the moon and saw this and took this photo. And every single person that has gone into space, everyone that has gone to the moon, everyone that has traveled to the International Space Station or traveled in some other spacecraft has all said exactly the same thing when they've returned. That as beautiful as space is, as amazing as the moon is, as extraordinary as it is to be in space, floating around in a spacecraft, the most amazing thing that they saw was the Earth. Every single one of them comes back saying how beautiful the Earth is and how, from that perspective out in space, it looks like such a beautiful, delicate thing hanging there in space. Every single one of them says the same thing, and I believe them. Now, if we leave the Earth and the moon behind and go on to the next planet, we'll see in the next slide that the next planet out from Earth or out from the sun is the planet Mars. This photograph of Mars here was taken by a probe as well, and just not that long ago, fairly recently. And you can see that it's a reddish planet. You can see at the top there are some clouds. At the bottom, there's a little bluish bit, and those are some clouds as well. So, and you can see lots of interesting surface features on Mars there as well. And if we look at the next photograph, please, we can see some extraordinary surface features. That dark mark that goes right across the middle of Mars there is a canyon system. And on Mars, everything is big. This canyon system is big. Mars may be a fairly small planet, all right, much smaller than the Earth, a little bigger than the moon, but the things on Mars are really, really big. And that canyon system going across the middle there is so big that the Grand Canyon would be the size of a tiny little tributary. If you stood in that canyon, there are places where the canyon's so big that the walls of the canyon walls are beyond the curve of the horizon. And you wouldn't even know you were in a canyon until you tried to walk out of it, and you eventually came to face with a wall of rock between 1 and 2 kilometers straight up. And you'd realize, oh, I'm down in the bottom of a canyon here. So on the left-hand side of that photo, you can see a couple of dark spots on Mars, and those are actually volcanoes. And if we look at the next photo, we can see one of those volcanoes up close. This volcano is the largest volcano in the solar system. It's about 600 kilometers across at the base. So we're here in the Hamilton area, all right, and if one side of that volcano were here in Hamilton, the other side of that volcano would be in Ottawa. And the height of the volcano is about 3 times as high as Mount Everest. Now, we've sent lots of probes there to Mars, and if we look at the next slide, we can see one of those probes there on the surface of Mars. This is the Curiosity rover. It landed several years ago. You can see it's on wheels, and it drives around on the surface of Mars. And it's taken a variety of extraordinary pictures, absolutely extraordinary pictures. This one is a selfie that the probe took of itself there on Mars. The camera that took this picture is on the end of a robotic arm, and it holds that robotic arm out, turns the camera around, takes a bunch of pictures of itself, right? beams them back to Earth where we assemble them together, and we get this. And there it is, a robotic probe on the surface of Mars. Absolutely extraordinary. Now, if we look at the next few slides, right, if we go to the next one, we'll see some of the amazing photos of the Martian landscape that that probe has taken. So we can go to the next slide, and we can go to the next one after that, showing some mountains in the distance. We can go to the next one after that, showing those mountains in different light. And one of the wonderful things about Mars is you can see how red everything is. You can see how the surface is very, very red. The sand is red. The rocks are reddish. There's red dust blowing through the atmosphere. And if we go to the next slide after that, right, we can see these wonderful sand dunes that made up of this sand. And the next one after that shows these wonderful red rocks. And even the sky looks red from the red dust blowing in it. All of that red is there from iron oxide, all right? It's actually rusty, all right? And that's what makes these extraordinary images, this extraordinary color. What an amazing planet. And every single one of these photos that you just saw is absolutely real. All these photos were real photos taken from the surface of Mars. Now, if we go to one more slide, we can see a sunset on Mars. And this sunset on Mars here looks very different from a sunset that we get, all right? Here on Earth, the sky is normally blue, and when sunset happens, it's red. But on Mars, the sky is normally that kind of reddish color, and a sunset is blue. So here we see a bluish-looking sun setting on Mars. The colors are reversed from what we usually see here. And there's a clue that we really are on an alien planet. And now if we go on to the next slide, I want to show you this. And it's not the prettiest photo from the surface of Mars, and it needs some processing. The photo needs some processing to get the color corrected just the way it should be. But what's really cool about this photo is it was taken by a brand new probe that just landed on Mars, okay, just last month, and it's called Perseverance. And it took this photo just a few hours ago on the surface of Mars. So, and I apologize, I can see here that the photo that you're looking at actually isn't the one that I wanted to show. It's been replaced by another one. So we can go on to the next slide, please. We can go on to the next one. So Mars, an absolutely extraordinary planet. There are a number of agencies today that are endeavoring to make a plan to send people to Mars. The hope is that we will be able to land people on Mars, just as we've landed them on the moon, and get a chance to, and we can move on to the next slide, please. And just as we've had a chance to see the surface of the moon up close, that's perfect. See the surface of the moon up close. Hopefully we'll get a chance to see the surface of Mars and see what it's like. Wouldn't it be amazing? And people of your generation are going to get to do this. People of your generation, people your age, are one day going to be walking around on the surface of Mars. It could be you. So, absolutely. Now, as we move past it, we now see this planet, which of course is the planet Jupiter. Jupiter is the biggest of all planets. It's bigger than all the other planets put together. You could fit all the others, including the Earth and all of them, inside Jupiter. So it's absolutely extraordinary. So now, one of the things that you can see about Jupiter here is that it's all swirly. It has bands going across it. It has that red spot down below there. And if we go on to the next picture, we can see more of the swirly clouds. All of these wonderful swirls of clouds that are on Jupiter. Jupiter is mostly made of gases. It's mostly hydrogen. It has some helium. And then the colors that you see here all come from other trace elements that make this up. Now, the banding, the striping on it is because Jupiter is rotating so fast that it stretches the atmosphere out into these stripes. Jupiter rotates around on its axis once every 10 hours. The Earth does it in 24 hours, 24 hours in a day, once for us to spin around. Jupiter, which is so much bigger than the Earth, does it in only 10 hours. It's moving really, really fast, and that's why you have these wonderful clouds on it, or these wonderful patterns in the clouds, I should say. So now, just as we saw some beautiful images of the surface of Mars, let's flip through the next few slides. Let's see the next one, and we can see some of these wonderful cloud patterns. It looks like a piece of art, but it's not. These are real photos of the clouds on Jupiter. And if we look at the next photo after that, it's the same thing. Real photo of Jupiter, the clouds on Jupiter. And if we look at the next one after that, this looks like a painting as well. These beautiful swirls of red and blue and that. So, and if we go on to look at the next one after that, again, more of the same beautiful artwork happening there on Jupiter. Now, if we go to one more slide, we can see this big red oval. And this big red oval here is a giant storm happening on Jupiter. And when I say a giant storm, what I want you to picture is a hurricane. I want you to picture a hurricane like we have here on Earth, a giant cyclonic storm swirling around. Only in this case, the cyclone there, the hurricane on Jupiter, isn't the size of a hurricane we have here on Earth. It's bigger than the entire Earth, all right, bigger than the entire Earth. In fact, you could put almost two Earths side by side inside that storm. And we don't know how long the storm has lasted so far. Many storms here on Earth last for days. Sometimes a giant hurricane might last for a week or weeks. This storm has been going for 400 years and maybe much longer. We don't know because we've only had telescopes good enough to see it for the last 400 years. It may have been going much longer. How much longer will it continue to go from now? We just don't know. We just don't know. It might begin to die out soon. It might go for hundreds of more years. If we look at the next photo, we can see a backdrop there with Jupiter. We can see some of those beautiful clouds. We can see it fading off into darkness on the right-hand side, and that's where the nighttime is on Jupiter. And then we can see that circle hovering in front of it. That's a moon going around Jupiter. Just like the Earth, Jupiter has moons. We have one moon. Jupiter has many moons, many, many moons. This one that we're looking at here is about the same size as our moon. And if we go on to the next slide, we can see it up close. This moon is called Io, and it's the most volcanically active place in the solar system. There are constantly volcanoes erupting on the surface of Io. I know, it looks like a big pizza. It looks like a big cheesy pizza, all right, with all these weird colors swirling around. But if you look right at the top, you can see that bit of blue shooting off the surface. That's a volcano erupting on Io right there. And on the surface where you see all the cheesy looking colors, right, it's that yellow color because it's made of sulfur. The volcanoes shoot out sulfur. Now, if you've ever had a chance to see a sample of sulfur here on Earth, you know that it's yellow, and that's not a surprise. There you can see how yellow it looks on the surface there. And we'll just hold on with the slides because we're getting a bit ahead of ourselves here. So we'll just hold on with the slides for a sec. And that yellow, the sulfur that's on Io is actually very, very smelly. If you've ever seen sulfur here on Earth, sulfur's very, very smelly. It's very stinky. It's not a good smell, not at all. It smells, a lot of people say it smells like rotten eggs, like if you leave eggs out too long and they go bad. So we find that when we find little bits of sulfur here on Earth, there's Io completely covered with sulfur. So not only is it the most volcanically active place in the universe, it's probably also the stinkiest place in the universe. The smell is probably just horrendous. Now, the slide that you had moved on to and that you're looking at now is another moon called Europa. And everything that you see there is ice. But if you could drill down under that ice, there's water underneath there. There's water that covers the whole moon. This whole world is covered in water, and on top of that water is an ice cap, just like in our Arctic Ocean, where there's the Arctic Ocean underneath and an ice cap on top where the North Pole is, right? That's what this moon is like, only it's the whole world here that's covered in an ocean, and then that whole ocean is covered with an ice cap. If you could get underneath that ice to the water underneath, the water is just like the water we have here on Earth. You could drink it. There are all kinds of things that live in our ocean that would be very happy living on the ocean of this moon here. And this moon is called Europa. It's a water world. So now if we move on to the next slide, you will see something that I'm certain you recognize. This, of course, is the planet Saturn. This is the planet Saturn. And you can see Saturn is all about the beautiful rings. Now this photo here, just like the photos of the moons of Jupiter and the clouds on Jupiter and the photos from the surface of Mars, these are all absolutely real photos, all right? These aren't illustrations. And the rings are just beautiful. They're absolutely beautiful. The rings, and if we look at the next slide, we can see a bunch of photos all put together into one picture that show the rings from different angles. The rings are made up of millions and millions of pieces of rock and ice, all orbiting around Saturn. And as they orbit around Saturn, they orbit around Saturn like millions of tiny little moons, right? Each one of these pieces of rock or ice most of them are small enough that you could hold them in your hands. It might take two hands to hold them, right? And the very biggest ones are maybe as big as your bedroom, maybe as big as your house, okay, for the very largest ones. But most are small enough that you could hold them in your hands. So if we look at the next slide, we can see Saturn with a straight line cut across it. Those are the rings seen from the side. These pieces of rock and ice orbiting around Saturn all do so on an absolutely flat plane. It's like a flat sheet of paper around the planet. The rings themselves are huge. They're vast. They're tens of thousands of kilometers across, but they're only a few meters thick. You could take an apartment building and put the ground floor of the apartment building below the rings, and the top floor of the apartment building would be above the rings. They're not very thick at all. They're very thin. And of course, also here we see that other circle in front of Saturn, and that other circle is a moon that goes around Saturn. In the next slide, we can see that moon and another one sitting in front of it. And that big moon in the back is called Titan. And Titan is also an extraordinary place, all right? It looks soft and fuzzy in this photo because it is soft and fuzzy. It has an atmosphere, and the atmosphere has clouds, and the atmosphere has haze, like a hazy day here on Earth. And just because it's a moon doesn't mean that it can't have an atmosphere and other interesting things happening. In fact, this moon that we're looking at here, Titan, is so big that it's actually bigger than the planet Mercury. If this moon were in orbit around the sun, we'd call it a planet. Absolutely. But it's not in orbit around the sun. It's in orbit around a planet, so we call it a moon. The planet it's in orbit around is Saturn, and this moon is Titan. If we look at the next picture, you can see through some of the clouds at some of the first surface features below. And those dark markings on Titan are actually lakes of methane gas. They're lakes of methane. It's so cold there that the methane is in a liquid state. And if we look at the next photo, this is a photograph taken by a probe that was falling down towards the surface of Titan, hovering on a parachute. We dropped it down and it parachuted down through that dense atmosphere. And it's kind of a weird looking photo because it's a bunch of photos all stitched together. You know what that's like, right? And you can see a landscape there. And down below it looks like a shoreline, and because it is a shoreline. That's a methane lake below with rivers of methane flowing into it. So, and then if we look at the next photo, this is a photo that that probe took when it landed on the surface of Titan. And you can see it's very orange looking. You can see the rocks there and the sand, all right? And we're lucky that the thing landed on land. It might have landed in one of those methane lakes and we wouldn't have got a photo like this. But there we can see this amazing color and this amazing landscape. And think about it, this photo, the very real photo, was taken from the surface of a moon that's in orbit around the planet Saturn. Just amazing. Now this next image that I'm going to show you here is an illustration, okay? This next one of this spacecraft that we're looking at here is an illustration. It's not an actual photo. This is an illustration. And this is a spacecraft called Voyager. The Voyager spacecraft traveled from Earth. We launched it from Earth and a long time ago in the 1970s. And it traveled out through space, and it traveled past the planet Jupiter, past the planet Saturn, past the planet Uranus, and finally past the planet Neptune. And we waited till it was just the right time when the planets were all lined up and we could send one spacecraft straight out and hit all these planets. And it went past Jupiter, and we saw swirling cloud belts. We saw volcanoes going off on that moon Io. And we saw that other moon that's all covered in water with ice on top. We saw that big swirling red storm that's twice as big as the Earth. And we were amazed at all that stuff that we saw. And then we went past Saturn. And as we went past Saturn, we saw the rings, and we saw Titan with its methane lakes on it, and other the little particles of the rings and little tiny ringlets, and other moons as well. And we were equally amazed. It was wonderful. And to travel from planet to planet takes many years. It takes about 3 years to go from each planet to the next. We waited 3 years to see those pictures of Jupiter. And then we waited 3 more years to get pictures of Saturn. And then we waited 3 more years to get pictures of the planet Uranus. And if we look at the next slide, we'll see what we saw when we got to Uranus. After waiting all of these years, we saw this completely blank, featureless disk. No fancy rings, no storms, nothing that we saw, no swirling cloud belts, nothing that we saw on the other planets, just this. And honestly, at first we thought that the camera was broken, and that we weren't seeing the picture properly, but we were. This is what the planet Uranus really is like. Now, there really are rings there, but they're very, very thin, and so they're tough to see. And there really is some weather, some swirling around in the atmosphere, but it's very faint and very soft. But my goodness, the planet's absolutely beautiful, isn't it? And there's something else extraordinary about the planet Uranus as well. The Earth sits on its axis and spins around once a day. So does Mars and Jupiter and all of the other planets. And they're not all perfectly straight up and down, but they're pretty close. They're pretty close. But the planet Uranus is not. For some reason, the planet Uranus is tilted completely over on its side. Why is that? Well, we think that what happened is that a long time ago, early in Uranus's history, it was hit by something else, something that literally knocked it over on its side. Just amazing. Now, if we look at the next picture, this is a picture of a moon that goes around the planet Uranus. This one is called Miranda. Now, it's kind of weird looking, very rocky and gray, and kind of an odd surface, right? And that's what I want to show you. But first I have to tell you this. With all of these, we found 2 moons that go around Mars. We found 60-something that go around Jupiter. And we found something like 70 or 80 going around Saturn, and a bunch more going around the planet Uranus. And that's a whole lot of moons to name. That's a lot. And thinking about what you're going to name all these things is really difficult and challenging. So when they got to the planet Uranus, they started to name all of the moons after characters from Shakespeare's plays. Plays like Romeo and Juliet. And there's a moon named Romeo going around Uranus, and another moon named Juliet. And lots of other moons named after other characters from Shakespeare's plays as well. This one is called Miranda. And Miranda has a surface that looks really weird. Some places, like on the left-hand side, it looks striped. Up at the top, it looks like craters. On the top left, it's kind of hilly. And then on the right-hand side, it's all striped. And then down just below the middle, there's like a backwards check mark, a white backwards check mark in the middle of a box. This is a really, really weird moon, and we had a really hard time understanding it until we finally realized that this moon was also hit by something. Now, you can see on the surface, you can see some craters, and those are places where it gets hit by meteors. But sometime in its past, Miranda was hit by something big, so big that it didn't just leave a hole or leave a crater in the surface. It was so big that it actually smashed the moon to pieces, and it broke apart into pieces. And all those pieces kept going around Uranus, and eventually their gravity pulled all the pieces back together, and it reformed into a second version of the moon Miranda, except it put itself back together a different way. Things that were on the inside were now on the outside. Things that were on the western hemisphere were now attached to things on the from the eastern hemisphere. All of these different pieces that you see here on Miranda are all pieces that were floating around on their own and then came back together. That's why it looks like this thing that's been put together the wrong way, because it has, right? So just absolutely amazing. So if we look at the next picture, this is the 8th and final planet in the tour, all right? This is the planet Neptune, all right? And Neptune, you can see, has some nice weather happening. It's nice and blue. What a beautiful shade of blue, and some good storms happening there. It's just wonderful. That blue comes from ammonia in the atmosphere of Neptune. So, and then if we look at the next slide, this is a slide that shows Pluto in the very best image we have of Pluto through a telescope from here on Earth. Now, Pluto isn't officially a major planet. It's what they call a dwarf planet. But I really, really love Pluto. Pluto's one of my favorites, you know. And this was the best view we had of Pluto. And it's not very good. We can see there's some bright spots. We can see there's some dark spots, but we can't really tell what's what. And that's because Pluto is so incredibly far away. It took until we were actually able to send a probe there. And we got this robotic probe to arrive at Pluto just a few years ago. And if we look at the next slide, we'll see that this is what the probe saw. And suddenly, Pluto has rich colors and lots of surface detail. And you can see there's bright spots and dark spots, just like what we saw through our telescope. But this is a really extraordinary view of Pluto. And we've never seen this through a telescope. We had to send a robotic probe out through space to actually go to Pluto to take this. Nobody's ever been there, of course, but the robotic probe took this photo. If we look at the next slide, we can see this is another view of Pluto taken by that robotic probe. And you can see how much ice there is on the surface. That's a lot of ice. And there's different kinds of ice. Some of it's made out of water. Some of it's made out of carbon dioxide. There's other kinds of ice as well as other things mixed into it. And they all blend together and make these beautiful patterns and shapes. So then again, as I said, these are real images of Pluto that you're looking at here. The next slide shows Pluto and some other large objects that are out there. And this is, as I said, Pluto's not considered a major planet anymore, and neither are these other things that you see here, okay, except for down at the very bottom, you can see a little piece of Earth for comparison, all right? But you can see some of these others, like Eris, and there's Haumea, there's Makemake, all right? Down on the bottom, right, there's Quaoar and Sedna, and these are other worlds similar to Pluto that are very, very far out there in space, way past Neptune. And I'm sure each of them is as extraordinary and interesting as Pluto is, and I would love to send a probe out there to see each of these up close. It must be wonderful. One that's a little closer is one that we can see in the next slide, and this is a world called Ceres. Ceres is farther away from the sun than Mars, but closer than Jupiter. And I skipped over it because it's also not considered a major planet. This is the largest of the asteroids. And although it looks really cool, I think it looks really cool, it's actually quite small. It's a lot smaller than our moon, all right? Even smaller than Pluto, right? So that's why isn't considered a major planet. But along with Ceres, there are many, many other asteroids. And by many, many others, I mean thousands, tens of thousands, thousands and thousands of asteroids all orbiting around the sun, a little farther away than Mars, a little closer than Jupiter is. So just wonderful. And there's one other kind of thing flying around out there in our solar system, along with all these planets and moons and asteroids. There's one other thing, and those are the comets. And if we look at the next picture, we can see a comet. This is a comet that actually appeared last summer, and it's called Comet Neowise. Now, the comet itself is a big, giant block of ice. So here's how I want you to picture a comet. It's a beautiful spring day today, but it wasn't that long ago that there were still these piles of ice and snow lying around. So I want you to picture going out and finding some of this very old, crusty snow. And in one hand, you pick up a handful of this old, crusty snow. And then in the other hand, you pick up a handful of gravel and dirt. And you pack it all together into the dirtiest, most disgusting snowball you can imagine. Now imagine that dirty snowball a kilometer across, or maybe even 10 kilometers across, and flying through space, and that's a comet. Now, if it's made of so much ice and snow, what happens when this big snowball gets too close to the sun? The ice starts to melt. And as the ice melts, it falls away from the comet, and that's what creates this beautiful tail, as we call it, coming from the comet. So in the big picture in the middle that you see there, down in the bottom left is a very bright spot, and that's where that block of ice is. And that yellow and blue streaks coming away from that bright spot, moving up and to the right, that's the dust and the ice, and that melting away from the comet and blowing out through space. The yellow stuff is the dirt, the blue stuff is the ice, all right? And that's the dirty snowball falling to pieces right there. So all three of these pictures here are of the same comet as it appeared in our sky last summer. And the picture in the top right shows Hamilton down below and that comet up above. So there's a little tour through our solar system. The sun surrounded by planets, and planets surrounded by moons, and then some asteroids and comets thrown in as well, all swirling around. But as we go on to the next slide, it's not just one solar system that we have in our universe. I promised a tour of the universe, so let's look at a few other things here. If we go on to the next slide, we can see an abundance of stars in the sky, all right? You've all been outside and looked up, and you see all kinds of stars in the sky, but there's a lot more going on there than just that. In this picture here, you can see a whole bunch of stars, and you can see gas floating around between them as well. If we go on to the next slide, we can see some of that gas up close, all right? This is a nebula. A nebula is a giant cloud of gas and dust floating in space. We give them names, and it's kind of like playing the game where you look at the clouds in the sky and say, oh, that looks like a rabbit, and that one looks like a horse. Well, we look at this one, and to many astronomers, this looks like a horse's head looking to the left. And so we call it the Horsehead Nebula. And it's this big cloud of gas and dust floating in space. If we look at the next slide, we can see what's called a constellation. And you know the names of some of the constellations. There's the Big Dipper, there's Taurus and Scorpius, and things like that, right? You know the names of some of the constellations. This one is called Orion. And you can see the bright stars of Orion. And one of the really cool things you can see in this photo is that the stars are not all the same color. Look at that bright star in the top left. All right, look at how orange it is. It's this orangey red color. That's a star called, and this is one of my all-time favorite stars, that's a star called Betelgeuse. And it really is that reddish color. You can see some of the others look really, really white. What color is our sun? Our sun's very white with just a hint of yellow. But look at Betelgeuse there in that photo. Stars really do come in different colors. Some are yellow, some are white, some are reddish, some are orange, some are bluish. They do come in different colors. Next time you're outside at night, look up at the sky and look at the stars very, very carefully and see if you can find any that are different colors. See if you can find one that looks a little yellow, or one that's a little red, or one that's a little blue. See if you can see that yourself. Now, another thing I want to show you in this picture is, see right in the middle, there's 3 stars right in a row, and then look straight down from there, and there's a vertical line with some stars, and the middle star in that looks pink. Well, let's look at the next slide, and we'll see why that star looks pink. It looks pink because it's another nebula, another giant cloud of gas and dust in space. It wasn't a star at all. And you can see the nebula, how pink the nebula looks. Now, deep down inside this nebula, the gas is collapsing, and it collapses down to form new stars. This is where brand new stars are made. The gas collapses down, packs into a ball, and that ball forms a new star. A nebula like this could actually make hundreds and hundreds of stars. And if we look at the next slide, we can see a cluster of stars that has come from a nebula like that. Once upon a time, our sun was part of a cluster of stars like this, a cluster of brand new stars that all formed out of a nebula. If the sun isn't part of the cluster anymore, because those stars have all wandered off into space. They're all in different parts of the galaxy now. But somewhere out there in the galaxy are a couple of hundred stars that are the brother and sister stars of our sun. So now, each of these stars out there, some are like our sun, some are very different from our sun. But I'm going to show you another one that's one of my favorites. If we look at the next slide, well, this isn't a star at all, of course. This is a picture from a movie. So this is a picture from Star Wars. And I mean the original Star Wars from back in 1977, long before you were born. But it's an awesome movie. And if you've seen the movie, you remember this scene where Luke Skywalker comes out of his home on his planet, and he's feeling really sad because all his friends have gone off into space to fight the evil galactic empire. But he hasn't gotten to go. And he comes out and he stands and he looks at the sunset and thinks about how sad he is. But when he looks at the sunset, he sees 2 suns. There's 2 suns there, right? And the people that made the movie probably did that to make the point that, hey, this isn't on Earth. This is a totally alien planet. There's not just one sun in the sky. There's 2 suns setting there. But the thing is, I've gone out in my backyard, looked through my telescope, and many times I've seen stars like this, where there's not just 1, but 2. If we look at the next picture, this is an actual real photograph of a pair of stars, just like that one from Star Wars. Here's 2 stars, side by side, floating in space. They're actually gravitationally bound to each other. Gravity holds them together, and they go around each other. Just like the moon goes around the Earth or the Earth goes around the sun, these stars go around each other in space. And if you were on a planet there going around these stars, all right, you'd have 2 suns in your sunset, just like Luke has in Star Wars, right? And you can see these out there through telescopes. I see them all the time. Now, you think this would be pretty cool, looking at 2 suns setting down behind your horizon. Have a look at the next slide. This next slide is what's called a globular cluster. And there isn't 2 stars here, or hundreds of stars, or even thousands of stars. A globular cluster can have hundreds of thousands of stars. The biggest ones even have 1 million. Imagine what it would be like to be on a planet going around one of these stars. Your night sky would have so many bright stars in it, it would just be ablaze with light. It would be absolutely extraordinary. So there, we've seen some nebula, we've seen some star clusters, we've seen a double star, and we've seen a globular cluster with hundreds of thousands of stars in it. But if we go to the next slide, we have one more category to look at, and that's beyond just our own part of the universe here, and that's out towards the rest of the universe. So if we go one more slide after that, after the title slide there, we are looking at a picture of a galaxy. We live in a galaxy. We live in a galaxy that looks just like this. This galaxy is made up of hundreds of billions of stars. All right? Hundreds of billions of stars. Our galaxy is just like this one, made up of hundreds of billions of stars, and our sun is one of those stars. One of those stars. And there's another couple of 100 billion beyond that. And our universe is full of these galaxies, absolutely full of them. Now, with so many galaxies out there, we can't come up with cool names for all of them. Some of them do have cool names, like the Andromeda Galaxy, or the Triangulum Galaxy, or the Whirlpool Galaxy. There's one called the Sunflower Galaxy. This one here does not have a cool name, because we can't come up with cool names for all of them. There are so many. So this one just has a catalog number. Now, I think this is a really beautiful galaxy, and I love this photograph, but it doesn't have a beautiful name. This galaxy is called NGC 4414. Not the most exciting name out there. This photograph was taken by the Hubble Space Telescope. And if we look at the next photo, we can see a picture of the Hubble Space Telescope in orbit above the Earth. It's a big telescope out there in space, all right? Now, I have a telescope, and I go out into my backyard, and I've seen all of the planets that we've talked about, and I've seen all the star clusters and galaxies and nebula and that we've talked about. But this telescope here is up in space, and that gives it a real advantage over telescopes down here on Earth, like my telescope, because it's above the clouds, above the rain, above the atmosphere, and away from all the light pollution that we have here on Earth. And so it has a beautiful, clear view of the sky. And that's why it's able to take such beautiful photos like that galaxy that I just showed you. That's one of my favorites. But now to finish the talk, I have two more of my all-time favorite pictures that I want to show you. And one of them was taken by the Hubble Space Telescope that you see there. The next slide shows what the area of the sky that the Hubble Space Telescope photographed. Here's how it works. The Hubble Space Telescope isn't owned by one person. It's available to anybody who has a good enough project to use on the Hubble Space Telescope. So what you do is you apply to have time on the Hubble Space Telescope. And if they think that your project is worthy, and they said, oh yes, that'd be a really good idea for the Hubble Space Telescope, then they'll do it. They'll point the Hubble Space Telescope at whatever you say, and then they take beautiful pictures, and you learn all kinds of amazing things. But the Hubble Space Telescope's a machine. So what happens if the machine breaks? Well, you would miss out on your turn, and that would be heartbreaking, because this is an extraordinary machine, and you can do amazing things with it. You really want to see cool stuff out there in space. And if it's your turn and it doesn't work, you'd feel sad. So what they do is they save a few days, and they save some time. And then if it isn't working on your day, well, that's okay, because we've got another day for you. And then you're happy because you didn't miss your turn. But what happened is, after many years, the Hubble Space Telescope had worked really, really well, and nobody needed to use their extra days. And after a number of years, the people that operate the Space Telescope realized that they'd saved up a whole bunch of extra time that nobody had ever used. And they said, what do you want to do with it? What do you want to do with all this extra time that we have on the Space Telescope? Do you want to point it at Mars? Do you want to point it at a galaxy? Do you want to point it at a nebula? No, they decided that they would point it at nothing. And so they picked a little spot. See that little box in the bottom there? Okay? Or in the middle, that little box in the middle that's labeled XDF, that stands for Extreme Deep Field. And it's a tiny little box, and the moon wasn't that close in the picture, but the moon is just superimposed on this, so you can see how small that little section of sky is that they looked at. And they took a photograph of this one tiny little empty part of the sky where they couldn't see anything. And they took one photograph that lasted for 10 straight days, because they had 10 days worth of observing time that they'd saved up. And now normally when you go out and you take a photograph, you go click and it's like 1/100th of a second, or maybe a 60th of a second. Well, this one wasn't 100th of a second. This one lasted for 10 straight days. And if we look at the next photograph, this is what it saw. Now right there, that may not look like much, okay? But almost everything you see here are galaxies. There's a couple of stars, but everything else is a galaxy. All the bright things that look like galaxies, but every tiny, faint little speck of light is a galaxy. And remember, a galaxy can have hundreds of billions of stars in it. In the original photo, okay, and this is the photo, the real photo that you're looking at, and in the complete file size, there are 5,000 galaxies in this one photo. And each of those galaxies has hundreds of billions of stars. And remember, this photo with 5,000 galaxies is the darkest, emptiest spot in the sky that they could find, a spot with nothing that they could see. And this is what showed up. I just love that photo. And now on to the next slide. One more title slide that tells us we're going home again. All right, one more slide that says and home again. If we move on to the next slide, we're back to that spacecraft, the Voyager spacecraft that we launched and went and visited Jupiter and Saturn and Uranus and Neptune. Remember that? All right, it sent back all those beautiful photos of swirling clouds at Jupiter and rings at Saturn, and then Uranus, which looked totally dull, but then had this awesome moon that got blasted apart, right? So, and then went on to Neptune. Well, the Voyager spacecraft, after it passed Neptune, it kept going. It didn't just stop there. It kept going on out into space. All right, and it's still going out into space. And even though it was launched in 1977, all right, 43 years ago, 44 years ago, it still works today, and we're still in touch with it, actually. In the next slide, we can see the path that it took. Launching from Earth out past Jupiter, Saturn, Uranus, Neptune, and out into space. And when it got out there into space and was still working, everybody started to think, well, what do we do with it now? We can't just put on the brakes and bring it back. It doesn't work like that. It's going something like 43,000 kilometers an hour. You don't just put on the brakes. It's going to keep going out into space forever. But what do you do with it? Well, if we look at the next slide, you can see what they did. They decided, what if we spin it around and look backwards with it? Instead of where we're going, let's look back at where we came. And they looked back towards the solar system. Now, these, of course, are illustrations, and this is an illustration here. And it shows you the photos that it took looking back towards the inner solar system. And you can see where Jupiter is on the left and Neptune is on the right. And you can see Uranus and Saturn in there and the other planets. And in the middle of those circles, way down in the middle, there's one box. And in that one box is the Sun and Earth and Venus. And Mercury doesn't even show up because it's so far away, all right? And it took a photo looking there. It looked back and took a photo straight towards the Sun, back so it could see the inner solar system. And if we look at the next slide, this is the photo that it took. Now that doesn't look very interesting, all right? It's got some kind of pretty colors, but other than that, it's kind of dull. but it's really, really impressive actually, because remember, this photograph was taken from outside the solar system, and when it has passed all the planets, and it's looking back towards the sun. And that's what those streaks of light are. It's glare from the sun. It's kind of like being in a car and looking out the windshield right at the sun, and it's so hard to see because the windshield's all streaky with glare from the sun. That's what's happening here. Those streaks of light, the yellow, the kind of brownish yellow one across the top, and the green one across the middle, and then the reddish and orangish ones, faint dull colors underneath that. Those are streaks of sunlight, all right, from looking back. But there's one other thing that makes this photo really, really special. Look at that top streak of light, that one that's kind of yellowish, all right, going from left to right across the top of the photo. Look about halfway along it, halfway along, near the middle, and then look just to the right of the middle in that streak of light. Do you see that little speck of light? See, there's one tiny little speck of light there, all right? It's caught in that sunbeam, that glare of light. That one tiny, tiny little speck of light is the Earth. That's the Earth, all right? As photographed from beyond the most distant planet out in interstellar space. That one little tiny speck of light is the whole world. Everybody that you know is on that tiny little speck of light. Everywhere you've ever been is on that tiny little speck of light. And unbelievably, it showed up from that far away. I love that photo. That's one of my absolute favorites. And if we look at the next slide, it'll remind us of just what that little speck of light is. The beautiful, beautiful Earth. And the very last slide that I have, if we go on to the very last one, the very last slide I have is a beautiful painting by an artist named Vincent van Gogh. And he lived back in the 19th century, all right? He died about 130 years ago, and he painted some beautiful scenes with the night sky and the stars in it. And here's a beautiful painting of his, and it actually shows some beautiful stars above the river, and you can actually see the Milky, or not the Milky Way, excuse me, you can see the Big Dipper in it. Absolutely gorgeous. It's so nice that he actually painted, that. And then the words at the top were the words of Vincent van Gogh, and I always liked those. I know nothing with any certainty, but that the sight of the stars makes me dream. And that's how I feel too. I think it's just fantastic. So that's the end of that. All right, that's the very last slide. You've all been very patient. Thank you very much. That took about an hour to take our little tour of the universe there and visit all of the planets and all of the planets and a number of stars and nebula and galaxies. So I really appreciate it. I'm so glad that you were able to tune in. I've taught astronomy for a long, long time, but I'm also part of a group of amateur astronomers, which means we just go out and do it for fun. And it really is fun getting out under the nighttime sky and seeing the stars and looking through the telescope. And some of these pictures from these spacecraft and from the Hubble Space Telescope are really, really extraordinary. But it's even more extraordinary to look through a telescope and see these things with your own eyes. They may not look as good as they do in the photos here, but to know that you're actually looking at Mars or Jupiter or seeing the rings of Saturn for yourself, right? Or looking at a very faint light in your telescope, but knowing that it's a whole other galaxy so far away in space really is an extraordinary thing. Really an extraordinary thing. And it's a wonderful, wonderful treat. So that's it. Thank you all very, very much. I really appreciate it. I wish you all the best at BASF. It's a wonderful, wonderful endeavor. Participating in BASF is something that I've enjoyed for many, many years, and I really, really hope that you enjoy it as well. I've seen so many extraordinary projects there, and I wish you well. Good luck at BASF, and thank you so, so much for listening in tonight. I really appreciate it.
Thanks, John.
John, thank you. Yeah, John, thank you very much. That was, can you hear me okay?
I sure can.
Okay, perfect. The pictures were absolutely amazing, and your passion for your love of the universe is absolutely shows through. You've captivated the audience. I can definitely tell. So, do you have a couple minutes for questions? There are a few questions that have come through.
I would be happy to. You bet.
All right. So there's a question going back to the moons. Are there any theories on how moons were created or formed?
Yeah, that's a really, really good question. So, and the answer, there's a number of different answers for different moons. So we think that our moon wasn't always there. We think that at one point the Earth was all by itself in space, but there was maybe another planet, a smaller one than Earth, that actually hit the Earth. And then when they hit, this bunch of material splashed off the surface of the Earth in this big crash, and parts of it went flying everywhere, flying out into space, and then it all coalesced, it all came together to form the moon. And when we look at the moon, the rocks from the moon, we can see that they're similar to the Earth, but it's not structured exactly like the Earth. And that's one of the clues that make us think that it happened in this big collision. Now, I'll be honest, we're not 100% certain of that, but we're about 99% certain that that's how it happened. Some of the other moons going around other planets arrived in different ways. They came about in different ways as well. But our moon happened when two planets, the Earth and another planet, crashed together and blasted out a bunch of material from the impact, and that material formed into the moon, which is still going around the Earth today.
Amazing. So we'll go over to Mars. Since the sand and rocks on Mars are rusted, which is caused by oxidation, do you know what happened to the oxygen on Mars?
Right, excellent. So good thinking. You're absolutely right. Very, very clever. So we know that actually there's a lot of that at one point in its history, Mars was very different than it is right now. Now the atmosphere is thin, it's cold on Mars, there isn't water flowing on the surface. We can see some clouds, we can see some ice, but there aren't any lakes or anything like that. But at one point in Mars's history, there was. At one point, Mars was warmer, the atmosphere was thicker, and there were lakes and rivers on the surface of Mars. And of course, lakes and rivers are filled with water, and water is made of hydrogen and oxygen. Now, where did all that water go? A lot of it seems to have evaporated off the surface, but some of it, we believe, is down below the surface, frozen underneath the ground like a permafrost. Well, here in Canada, if you go up north, to the very far north, there's a permafrost that stays frozen under the ground all year round, even in the summer. We think Mars is like that now, and if we can dig down underneath, we'll find a lot of that ice buried underneath. So, but at one point, that ice was on the surface, it was in the form of water, and of course, water is full of oxygen, and water is really, really good at rusting things. So that's a great question. Really good thinking that since it was oxidized, there must have been oxygen there sometime. Good for you.
Great. So we'll jump to Jupiter. Which type of probe is actually stable enough to go into Jupiter? Those pictures are fabulous, is the comment as well.
Oh, I'm glad you like them. I really like them too. Those pictures are fabulous. So we've actually sent several probes to Jupiter over time, and some have gone into orbit around them, and some have gone down into the clouds. And when you go down into the clouds, the atmosphere gets so dense that the probe actually doesn't last very long. And this is a good reason to robotic probes and not people, because as it goes down towards the clouds, it actually ends up getting crushed. So if you're actually asking what kind of probe is good enough to stand going into Jupiter, none of them are. They all get destroyed as they go down into Jupiter. But we're able to get all kinds of great information about what Jupiter's made of, what the clouds are made of, what the wind speeds are like, and of course we also get those beautiful, beautiful photographs.
Amazing. Okay, a couple more questions. When was the last time a major space object, like an asteroid, hit the Earth? I know there are lots of craters, such as the Brent crater from many years ago.
So very good question. So that's right. It's not just the moon and Mercury and Mars and these other places that get hit. The Earth gets hit as well. We know that in the past there have been some major impacts. There have been some really, really big ones. And now, so things like, I didn't have a picture of it here in our show tonight, but there's a place in Arizona where in the flat desert of Arizona, it's just flat desert as far as you can see, and then just in the middle of nowhere, there's a hole in the ground that's 1 kilometer wide. This great big giant hole in the ground, and that's because something hit there and blasted that hole out. So that was probably about 10,000 years ago. There are others that are much older, and it's believed that a major impact might have been what helped kill off the dinosaurs millions and millions of years ago. So there are impact sites that happen around here, but lots of little impacts, well, the tiny little ones, are happening all the time. You've probably seen a shooting star. Most times a shooting star is a little piece, a tiny piece of meteor that's about the size of a grain of sand, and when it hits the Earth's atmosphere, it lights up and you get to see it falling down as a shooting star. That kind of thing happens all the time. On a night where there's a meteor shower, you can see lots of them happening. And sometimes, even today, even bigger ones hit, big enough for a rock to fall all the way down to the ground. And if you find one of those rocks, you can pick it up and you have a meteorite. And that's a really fantastic thing. If one lands in your yard, yay, that would be awesome. Not likely to happen, but, it would be great if it did. So big ones hit very, very, very rarely. And we don't worry that much about a big one hitting us because it happens so infrequently. But little ones are hitting us all the time, and it's really cool. They're really beautiful when you get to see shooting stars. So thanks. That was a great question.
All right. I was actually intrigued with this question too. What gives a star its coloring?
That's a really, really good question. And this is one of my favorite things. That's really cool. So a star gets its color from its temperature. So I want you to picture looking at a candle and a flame on a candle. And if you look at a flame on a candle, right away you think, oh, it's yellow. But if you look very carefully, the very outer rim is red, and then most of it's yellow, and then down towards the very center, right in the very center where the candle is lit, it's blue. It's very often blue. And those different colors are different temperatures. And blue is where it's hottest, and red is where it's coolest. You can also imagine turning a burner on in your stove, not if you have like a flat top stove or that, but if you have a burner on your stove and you turn it on, as it gets hotter, it starts to heat up red, right? If you could turn it up super, super hot, it would actually turn blue. And that's what's happening with the stars. A red star is a cool star. A yellow star's in the middle, that's like our sun. And a blue star is much hotter than our sun. So a blue star can be super hot, right? A red star is very, very cool, right? So when we look at a star and we see a different color, it's actually giving us information. It's telling us what the temperature of that star is. And we can tell exactly what the temperature is by checking the exact shade of color of that star. And then once we know what the temperature is, we know that to get that temperature, it has to burn a certain amount of fuel. And by how much fuel it's burning, that tells us how long the star will last before it runs out of fuel, and all kinds of other things about it as well. So even though it's just a pretty color, it actually tells us all kinds of useful information. So the color of a star tells us the temperature of a star, and then it goes on from there. So that's a great question. Well done.
You have great answers. A couple more questions. You're okay with that?
Absolutely.
Okay. How do we know that Miranda broke apart and reformed in a different way?
Okay, so that's a good question. So now, and one of the things that makes that a good question is that us astronomers are asking that same question. So when we first saw the pictures of Miranda from the space probe that went there, that was the Voyager probe that went there, and we looked at it and we said, oh my, that's a really, really weird moon. It's all different in different sections. That part's hilly, that part's cratered, that part has straight lines in it. It's a really, really weird looking moon. And we wondered what kind of processes, right, geological processes, would create a surface that looks like that. And we couldn't come up with anything. Eventually, somebody had the idea, maybe it wasn't one process. Maybe, that put all these things side by side. Maybe, and they came up with the idea that it was smashed apart and put back together. Now, I'll tell you the truth. One of the things I really like about astronomy and exploring space is that there are still things to learn. We don't have all the answers. When I started doing this, when I was your age, we knew a lot less then. We've learned so much. I've learned so many new things. We've discovered so much. It's wonderful. And we continue to discover new things. And that's an exciting thing, that there are always new things to discover, new parts of space and new sections in the universe to explore, new things to learn. But sometimes it means that there's something we haven't learned yet, and it's waiting to be discovered. Our idea that Miranda was smashed apart and then put back together is a really good idea. It's the only idea we have so far that explains what we're seeing when we look at Miranda. But the truth is, we don't know when it happened. We don't know how it happened. We're not even 100% sure if it happened. It's the only thing we can think of that explains that look. And that is one of the great things still to be learned. I would love to send a probe to Miranda, explore the surface, and find out for sure what happens to it. Sometimes in astronomy, the answer is we don't know yet. Sometimes the answer is we haven't figured it out, we haven't discovered it, it's still waiting to be unearthed, waiting to be discovered out there in space. And I love that about this science. I love knowing that there's something more to learn, there's something else to discover, and I love thinking about what is it that tomorrow is going to bring, and what are we going to learn then, right? Hopefully, one of these tomorrows, we're going to learn more about Miranda. So you asked a really good question, because that's a question that us astronomers are still asking as well. So that was a good one.
We have some smart viewers. So next question, what would be the oldest element in the universe?
So the oldest element in the universe is, and yes, very smart people here, the oldest element in the universe is hydrogen. So when the universe first formed, it started out forming with hydrogen. And hydrogen, right, through the process of nuclear fusion, a nuclear fusion reaction where hydrogen atoms are brought together, then went on to form helium. Helium's the second oldest. And then from helium, hydrogen and helium, it carried on to form all the others. Hydrogen is the oldest, and hydrogen, through a nuclear fusion reaction, formed helium, right? And that reaction is happening inside stars today. Our sun is doing that. Our sun is made mostly of hydrogen, and it's in the process of turning that hydrogen into helium through a nuclear fusion reaction deep in the core of the sun. And the energy that comes from that reaction is what creates all of the light and heat that the sun emanates, and the light and heat that shines down on us. So when we go out on a beautiful day like today or tomorrow, and we enjoy the sunshine, that energy started out with hydrogen atoms deep in the sun being turned into helium. And hydrogen is how the universe started out, full of hydrogen. Everything else has come from that.
Amazing. There's a couple questions about black holes.
Well, I hope so, because black holes are so interesting. We should always have a question about black holes.
So I'll sort of read the three questions and you can formulate an answer. What is at the end of a black hole? Some of the theories say that it is like a wormhole, but I would like to know your opinion. Is a black hole just a vacuum? And what happens to the matter after being drawn into a black hole?
Very good questions. So black holes are some of the most interesting and mysterious things out there in space. Absolutely. So black holes are places where gravity is so strong that nothing can escape. So you go outside into the yard, you take a baseball, you throw it up into the air, the baseball goes up, it slows down, it stops, and it falls back down, and you catch it in your hand. You're playing ball. Throw the ball up, it falls back down, and you catch it. That's the Earth's gravity slowing it, stopping it, and pulling it back. If you throw the ball harder, you can get it to go higher, but eventually it still comes back down. You need something like a rocket to get completely away from the Earth's gravity so that it keeps going up. And that takes a lot of energy. What if the Earth had even more gravity? That takes even more energy to get away. Well, a black hole has so much gravity that there isn't enough energy in the universe to escape out of a black hole. Not even light shining from it can escape out of a black hole. And that's why it's black, of course, because not even light can get out. So things can fall into a black hole, but they can't get out of a black hole. So what happens when something falls into a black hole? Well, really, really weird things happen when you fall into a black hole. So now I wouldn't want this to actually happen to you to the people that ask this question. I wouldn't want this to happen to you, but imagine that you were falling into a black hole. As you fell towards the black hole and you got closer to it, the gravity would start to get stronger. And the gravity would get stronger and stronger, and it would get super strong as you were falling towards the black hole. And it would be so strong that if you were falling feet first towards the black hole, your feet would feel more gravity than your head does. And your feet would start to fall towards the black hole faster than your head. And if your feet were falling faster than your head, you'd start to stretch out. The black hole would start to stretch you out, and you'd get taller and taller, which sounds funny at first until it isn't funny, because you don't want that to actually happen to you. But eventually, as you fall to the black hole, toward the black hole, you would get stretched out so much that you would end up looking like spaghetti. And astronomers, honestly, this is the absolute truth, okay? Astronomers sometimes don't always come up with the best names of things, right? Like that galaxy I showed you called NGC 4414. Well, when things fall into a black hole and they get stretched out so much that they look like spaghetti, astronomers actually call that spaghettification. So if you fall into a black hole, you experience spaghettification, and you get stretched out into a black hole, and then you actually go down into the black hole. Now, light can't get out from a black hole, matter can't get out from a black hole, you can't get out from a black hole, and even information can't get out from a black hole. So what happens once you're in the black hole? Well, of course, nobody knows, because you can't get information out, right? But we suspect that what happens is that you then contribute to part of the gravity of the black hole, and the black hole just gets more gravity because of what you've added into it. So is it what happens to matter that gets drawn into a black hole? It gets spaghettified and then ends up in the black hole, making the black hole even bigger and stronger. Is it just a vacuum? Well, No, because in fact, it's not just a vacuum, because the gravity is so strong that it can actually suck in the space around it, and the space ends up warped and torn, and you end up with this tear in space because the gravity is so strong. We say it's black because even light can't get out, and we say it's a hole because the gravity is so strong, it tears the fabric of space, and so it's a black hole. So is it just a vacuum? No, really weird things happen. It's much more than just a vacuum. But what it's actually like to end up down inside the black hole, well, nobody knows, because we've never gotten an answer out from inside a black hole. We just don't know. So there's another one of the mysteries of the universe I'd love an answer to. Absolutely.
That's amazing. Thank you so much, John, for your time and for your amazing pictures and for answering the questions. Your support for BASF over the years has been extraordinary. Thank you. And everybody that's still on, thank you for joining us tonight. Our next activity, live event, will be tomorrow at 7 p.m. and we'll be talking about some of master engineering programs for students grade 9 to grade 12. And so we hope you join us then. And thank you again. Have a wonderful night.